Hello everyone. In this video, we will be talking about graph databases. In this introduction, we are going to show you several types, uses, advantages and some examples to let you understand what is all about graph database. A graph databases are no SQL type database. It is used to overcome the shortcomings of relational database. A graph database is a database that uses graph structures to represent semantic queries. Graph databases enable for fast and easy retrieval of data by layout. It stores, modifies and queries a network graph efficiently. It stores data that prioritizes relationships and connections. A graph database consists of nodes and edges. A node represents the data entity. The edges represents the relationship between two nodes. Each node is assigned a unique identifier that expresses key value pairs. The relationship allows data to be linked together directly. Relationships always has direction, a form, a start and end node.
The uses of graph database is to solve the many-to-many relationship problems. Second, it reduces latency in create, read, update and delete operations. Graph database is used in recommendation engines such as rating 5-star. It will do the comparison among the restaurants and show the top 3. Graph database is widely used in our social networks such as Facebook. This is how we can know the number of mutual friend. What are the advantages of using a graph database? First advantage is having a constant performance. For the traditional databases, relationship queries will come to a grinding halt as the number increase. In contrast, graph database performance is constant since that traversing a given vertex's neighbor nodes via edges are independent of the graph size. Next, it is increased flexible compared to the other database. This is because the structure and schema of a graph model flexes as applications and industries change. They can add to the existing graph structure without endangering current functionality. Third is agility, which means can develop a database quickly and easily. This enables the graph database to evolve in step with any changing business requirement. There are different types of the graph databases. The first one is property graph, second is hypergraph and the third one is the Triplestore.
In the property graph, data is organized as nodes, relationships, and properties. Nodes are the entities in the graph. An entity can be a person, place, thing, category, or other pieces of data. They can hold any number of properties. The relationship represents how two nodes are associated. A graph relationship always has a start node, an end node, a direction, and a type. Relationships can also have properties like weight or distances. For hypergraph, it is a graph data model in which the relationship can connect to any number of given nodes. It's useful when data includes a large number of many-to-many relationships. Let's look at an example. Alice and Bob are the owners of the mini car and Audi car, but at the same time, they also be the owner of the Chris car. For Triplestore, the addition of information is represented with a separate node. A Triplestore is composed of nodes and arcs. However, the Triplestore is not a native graph database because they don't support index-free adjacency. There have an example of Triplestore used to point the address in the network. Let's look at an example of graph database. We'll use Twitter for this. Imagine a user first posts a tweet and the tweet mentions another user. The tweet's content is using a source where it has a link. The tweet is tagged by an hashtag. This tweet was also retweeted by another user to reply another tweet. And with graph database, we are able to represent more complicated relations that helps us to visualize the relationship between different entities better and clearer. Summary for the day. We introduced what is graph database. What are the benefits and uses of graph database? How different types of graph database works such as property graph, hypergraph and Triplestore, and an example of graph database usage.
Thank you.